In this chapter, we're going to study trigonometry. In this lesson, we're going to use the sine law to find a missing angle.
Okay. Hi everybody. So in this lesson here, we're going to use the sine law again. So in a previous lesson, we used the sine law to find sides, and that was solely our goal there. Now we're going to use the sine law to find angles. Okay. It's the same rule. Okay. It's still the same rule here. We're still looking at A over the sine of A equals B over the sine of B equals C over the sine of C. But at the very end here, to find an angle, to find an angle, you end with the inverse sine of something. Okay, so we're going to set up the ratio. We're going to get sine equals to something, and then to get the angle out of that, we're going to have to use this final operation here, this inverse sine. It's just like anytime you use the Pythagorean theorem, the last thing you got to do is the square root. Here, if you're using the sine law to find an angle, the last thing you got to do is this inverse sine here. Anyway, let's take a look at some examples. It'll make way more sense once you've seen it done a few times. Okay, so here we go. Let's take a look at this example here. We're going to find the value of angle B. So this is the one that we want right here in each of the following. So right now, when I look at this problem, I see that I've got this angle and I've got that side. That's the piece that I need. I need that connection right there. And then the piece that's opposite the angle I'm looking for here is this 10. So here we go. We're going to set up the sine law. So first of all, I'm going to start with this ratio. So 14 over the sine of 115 degrees is going to equal 10. In this case here, now I know the length of the side opposite. What I don't know is the angle there. Now, I still cross multiply. So it's still going to be 14 times the sine of B is going to be equal to 10 times the sine of 115 degrees. I'm still going to divide, but in this case, I'm going to divide by the 14. I want to get the sine of B by itself. So I'm going to divide by that 14. So I get the sine of B is equal to 10 multiplied by the sine of 115 divided by 14. Okay, well, here we go. Now I've got the sine of B equal to this number here. Now, and it is just a number, because remember, the sine of 15 is just a ratio. It's just a decimal value. Okay, the calculator knows what it is, even if I don't. So I'm going to let the calculator handle that. The last thing I got to do is get rid of this sine here and figure out what B is. So B is going to be equal to the inverse sine of that whole expression. So 10 multiplied by the sine of 115 over 14. Oh, I have a little tail on my 14. I'm just going to get rid of that. I don't know why I did. That looks way better. Okay, so now let's plug that into my calculator. And actually, I can plug that all in exactly the way it looks. I'm going to do the inverse sine of. Okay, now, and I can do this all in one step. You can do it in a couple of steps here, but you make sure that you do whatever's inside here first, then do the inverse sine of it. But I can put it all in here. 10 times the sine of 115 divided by 14. And so I just make sure that there's a set of brackets around that whole thing. And when I press enter, I'm going to get 40 degrees. I'm going to round that to the nearest degree. Usually we take angles to the nearest degree. And there we go. And actually, that makes sense here. I knew that my angle here had to be less than that 115. Okay? So let's take a quick look over here. So once again, the pair that I've got is this pair right here. Okay? What I don't know is angle B. And so I walk through this very, very much the same way here. It's going to be 5 over the sine of 71 degrees is going to equal 7 over the sine of B. Now, I'm going to make a quick prediction here. Because the side here, 5, is smaller than this side right here, I think this angle is going to be smaller than my B. Okay, I think my B is going to be larger than 71. So we're just going to make a prediction here and just see if that works. So when I cross multiply, 7 times the sine of 71 degrees, okay, is going to equal 5 times the sine of B. Divide both sides by that 5 because I want to get rid of that coefficient here. So 7 times the sine of 71 degrees over 5 is going to equal the sine of b. I'm almost there. Now to get b by itself, I simply take the inverse sine of that whole thing there. So 7 sine of 71 degrees over 5. Okay, and that is just calculator work. So let's take a quick look. And again, I'm going to do it all in one step. So the inverse sine of 7 multiplied by the sine of 71 divided by 5. I'm going to close the brackets up there. And I get a domain error. Okay, well, what does that mean? So I go back to this and I think, okay, let's take a look at what's inside. Maybe we got to do this in pieces here. So let's go down here. Whoops, okay, this is going to make me go back here. I gotta quit out of this. Let's do 7 times the sine of 71 divided by 5. Oh, right there. See, this is something that we haven't talked about here in this particular course as we've gone through this. But the sine ratios always have to be less than 1. Because sine is the opposite side over the hypotenuse, and the hypotenuse is always the largest side in a right angle triangle. So that ratio has to be less than 1. So right here, when I tried to take the inverse sine of this, I was doing it with a number that was larger than 1. That doesn't work. And so what happens here is we get, there's no solution here. Basically because this particular scenario is not possible. Okay? Anyway, so that's an interesting thing. I wanted you to be able to see that. Okay, so in this set of problems here, we're also looking for the value of b. Okay, so let's set this up here. Let's take a look at what we're given. So in this particular problem here, notice that I'm given this angle right here and that side. So that's where we start. So I know right away that my sine law is going to start with 15.0 over the sine of 38 degrees. And that is going to equal, okay, well look at that. I am wanting angle B, but that would mean I would need this side right here. I don't have that. What I have is this side right here, and that is opposite angle C. Okay, well everybody, that means the only thing I can solve for is angle C. I can't get B right away here. So this has got to be 19.8 divided by the sine of C. Okay, well, carry on. Keep moving forward with this. So that is 15.0 multiplied by the sine of C. And this is 19.8 times the sine of 38 degrees when you cross multiply. Now I'm going to divide by the sine of 15. Sorry, sine of 15. Just the 15. To get the sine of C by itself. So that'll be 19.8 sine of 38 degrees over 15.0. And then to get C all by itself, I'm going to have to do the inverse sine of 19.8 times the sine of 38 over 15.0. Okay, so now that is once again just calculator work. So the inverse sine of 19.8 times the sine of 38, close that bracket there, divided by 15.0. Okay, and I get 54 degrees here. So C is 54 degrees. Well, okay, how does that help me get B? Well, I know that the sum of the angles in a triangle has to be 180. So what I can do here to get B, I can take 180 degrees, I can minus the 38 that I was given, and then subtract the 54 that I just figured out. Okay? So 180 minus the 38 that they gave me, minus the 54 that I just figured out, 88. So I know that B is going to be 88 degrees. Okay? Except, does that make sense? No, it doesn't, does it? Something about that doesn't make an awful lot of sense. And this is one of the problems that we're going to bump into with trigonometry here, okay? Particularly with the sine law. Now, we're not going to get into this in this particular course here, okay? Because it's not specifically part of our curriculum here. But there is something called the ambiguous case of the sine law. And we just bumped into that. Okay, we just bumped into that. Now, I know that because of the way this is written up here, that these sides here should work out where, so this would be open up, this is opening up to the smallest side. This looks like it should be an obtuse triangle, okay? Except my information doesn't come out to look like it's obtuse. That angle should have been larger than 90. Okay. Now it turns out, based on the information that I've given you, I can draw a triangle properly that has these 3 bits of information. It's just that the angle for B ends up being 88, ends up being a little bit different than this. There is another situation that pops up though, that where this information would also work, and it's also a different triangle. Now you don't need to worry about that at all. You don't need to worry about that at all. I'm just showing you a possibility here. So it is true. What I've done here is correct. Okay, 54 does work, 88 does work. It's just that this is one possibility of 2, and what I've drawn here in terms of the triangle is the other possibility. Okay, so just like there was a weird issue over here where all of a sudden, nope, triangle doesn't exist, here we've also got a bit of an issue. Okay, now let's take a look at this problem again, and here, once again, we're still looking for B, okay? I have given you this angle here is 56, this is 60, so I have that pair. And then once again, although I am looking for B, the information that I've given you doesn't allow me to solve for B. I got to solve for C first, okay? So let's set it up. So 60 over the sine of 56 degrees is going to equal 70 over the sine of C. So cross multiplying, 60 multiplied by the sine of C, okay, is going to equal 70 multiplied by the sine of 56 degrees. Then I'm going to divide. So sine of C is going to be 70 sine of 56 degrees over 60. So C is going to equal the inverse sine of 70 sine of 56 degrees over 60. And now that is just calculator work, so we'll just kind of push that off to the side here, pull out the calculator, clear that up. Whoops, sorry, clear that up. So the inverse sine of 70 sine of 56 divided by 60, close brackets, and we're going to get 75 degrees. So we'll put that down there, 75 degrees. Good. Now let's take a look at B. So I know that this is 75 degrees. So B is going to equal 180, the sum of all the angles, minus the angle that I was given, minus the angle that I just figured out. Okay, so 180 minus 56 minus 75, and I get 49 degrees. Okay, so nothing really weird about this one right here. This is the kind of the standard procedure that I'm going to get you to follow here. So was this one, by the way. It's just that this one, again, your answer didn't quite match with what I was seeing here, because that is a possibility. Okay, it really only happens when you're using the sine law to find an angle. I don't want you worrying about it. I just want you to work, continue to move ahead. Just do exactly what we did right here. Use this one as your example as we move forward here, and that should be fine.